Okay, so next up we want to evaluate the indefinite integral as an infinite series. And so we know that arctan, so in order to do this, first we need to figure out the infinite series for arctan. And then you put in x squared in the position of x to figure out the infinite series of arctan x squared, and then we're going to take the integral of all of that. And so we know that arctan x, or inverse tangent, is going to be the integral of 1 over 1 plus x squared. And then we're going to make use of our little friend here that just simply states that 1 over 1 minus x can be expressed as the infinite series from n is equal to 0 to infinity of x to the power of n. And so now when we substitute in 1 over 1 minus negative x squared, which is what we have here, 1 plus x squared, you simply put in the negative x squared in the position of x. So n is equal to 0 to infinity, negative x squared to the power of n. We can pull out the negative as a negative 1 to the power of n and leave this as x to the power of 2n. So let's write that all out. So it's from n is equal to 0 to infinity of negative 1 to the power of n multiplied by x to the power of 2n. So that means that we can express arctan of x as the integral of the summation, so the infinite series, negative 1 to the power of n, x to the power of 2n. Okay, and so now, because these two don't really involve, sorry, this is over dx. Because these two don't really involve any x dependence, the only thing that we're going to be really integrating here is going to be the x to the power of 2n. And just remember that the integral of x to the power of a is going to be 1 over a plus 1, x to the power of a plus 1. In this scenario, our a is going to be equal to 2n, and our a plus 1 is going to be equal to 2n plus 1. So this means that arctan of x is going to be, as mentioned, the integral of this infinite series. And to write out what that is going to be, it is going to be the summation from n is equal to 0 to infinity of negative 1 to the power of n, x to the power of 2n plus 1, all over 2n plus 1, according to this formula. So now we just put in our x squared, since we have what arctan x is. So arctan x squared is going to be from n is equal to 0 to infinity, negative 1 to the power of n, x squared to the power of 2n plus 1, all over 2n plus 1. We know that we're going to multiply these two according to exponent rules. So it becomes from n is equal to 0 to infinity, negative 1 to the power of n, x to the power of 4n plus 2, all over 2n plus 1. Okay, so now we need to remember that the question is asking for the integral of arctan x squared. So let's go ahead and find that. And that is going to be the integral of what we have here. So from n is equal to 0 to infinity, negative 1 to the power of n, x to the power of 4n plus 2, all over 2n plus 1. So again, similar to how we did the one here, because x to the power of 4n plus 2 is the only variable with x dependence, we're just going to use this same exponent rule when it comes to integrating. And so our a is going to be 4n plus 2, which means our a plus 1 is going to be 4n plus 2 plus 1, which is 4n plus 3. Which means that this will become the infinite series -1 to the power of n, x to the power of 4n plus 3, all over that 2n plus 1 will still be there, multiplied by 4n plus 3. So this one is from the first integral we found to find arctan in the first place, and then the 4n plus 3 is from integrating arctan x squared itself. And so this is going to be with the radius of convergence of 1. And that's our final answer.